At night.
Yeah, sure. Okay, thank you. Okay, now, so this is a microphone and a recorder. Yeah, okay. I'm just wondering, could that light maybe be dimmed?
Oh, it's nice to keep the light on you.
Oh, I see. What if I stand over this side? Yeah, that's right. Okay, so thanks so much for inviting me. It's really great to get up here. I think out of all the societies, I have probably the closest affiliation with the Auckland Astronomical Society. I've known Grant, Christy for many years, Jenny, Bill, Andrew, Nalani and Gareth, and so on. So it's really great to get up here and say hi to everyone, and I'm sorry if I missed anyone in that. So basically my talk is entitled The Possum Comes Out at Night, which is, if you're wondering what the heck does that mean, is because my observatory is called Possum Observatory. So I'll explain why it's called Possum Observatory shortly. So tonight in this talk we'll discuss my setup in Gisborne, astrophotography that I do, comet and asteroid astrometry, microlensing, occultations, spectroscopy, galaxy interactions, meteor observings, and recent academic studies. Now, is there a clock up there? Oh, yeah, there, good. Okay, just to stop me rabbiting on too much. Okay, so the beginning of my astronomy, we just finished the Royal Astronomical Society of New Zealand conference in in Wellington, just on the weekend. And so some of this talk here is from the Fellows talk that I gave there. In fact, it was slightly like Jenny's talk, where Jenny gave a bit of a photographic overview of her life when she presented her Fellows talk. So this was very much a picture one for that Fellows talk. So I've stolen one or two slides in case they don't quite marry up. But anyhow, so my astronomy started with this lady here, my mother, and June Drummond. In fact, her name is June Dawn Drummond, because she was born in June, in the dawn of the day. So it was one day, Mum and I, when I was 10 years old, we went to the swimming pool here. It's called the McRae Baths in Gisborne. And it was very popular with the young people back then. And there's a restaurant there now, and the pool's been filled in, sadly. But we went there, and on the way back from the McRae Baths, when Mum was about this age here, these are her brothers and sisters and in-laws. Mum pointed up as we were walking along Rootney Road, and she said, "Look, John, there's the pot." And the pot, as you know, is the belt and the sword of Orion. And from New Zealand, or the Southern Hemisphere, basically it looks like a pot. And when she pointed that out to me, here it is here, the pot, you can see the base of the pot and the handle and the other side of the pot there. The pot for us, but for the Northern Hemisphere, they see the shoulder, head, belt, sword hanging down, and the leg of Orion, the mighty hunter. But for us, in this, New Zealanders, we call it the pot. And something just went off in my head. I was absolutely fascinated with astronomy. I don't know what it was. It was like something, the top of my head was lifted off, and astronomy, the universe, just poured in, and I've been like that pretty much ever since. And it's really funny, whenever I buy a new telescope, which costs quite a lot of money, Mum always says, "Why the heck did I point the pot out to you?" So yeah. So the first telescope that I got was a 30 centimetre refractor. Sort of did the job okay. And then after that, got a 60mm refractor. This is when I was at Ilminster School, an intermediate school, about 12 years of age. And there were two things that I got interested in at that stage. One was astronomy and one was surfing. And interestingly enough, those are the two things I do all the time now. Astronomy during the night and surfing during the day. Oh, and you have to work every now and again. So yeah, I teach science at a high school. So so I got into surfing back then. That's me when I was about 10 or 12 years of age, surfing. And there I am posing on my surfboard back in the day. So that's a refractor I had, and I used it every clear night I had. And interestingly, there's a ladder back here, And what I used to do was climb up the ladder, and there was a flat roof just on the other side of this fence there, and I could stand on that, walk along, and then jump up onto this garage here, and I'd take my sleeping bag up there, and I'd lie on the roof of the garage and just lie there and watch meteors and do meteor observing. So it was really, really quite a special time. I told this story at the Fellows Conference one night. Mum went in to say goodnight to me in bed, and I wasn't there, and she said to my brothers, "Where's John?" They said, "We don't know." They all searched around outside and everything up and down the road, and I wasn't there. They phoned my friends' parents and said, "Have you seen John? We can't find him anywhere." No, we haven't seen John. And they were almost getting to the stage of phoning the police because I thought I'd been kidnapped. And my second oldest brother turned up, came home, and they said, "We can't find John, we can't find John. Have you seen him?" And he said, "Yes, he went meteor observing." And they got a torch and went up there, and there I was sound asleep in my sleeping bag with my feet stuck in the gutter so I wouldn't actually fall off the gutter. So I spent a lot of time under the stars in Gizzy at that place there. And at that time I used to do a lot of sketching of what I'd see in the sky. Tried to write as many observations down as I could. This was me when I was 13 years old, and it's something I still do. I still keep a log of what I do, what I photograph, and everything, and it's turning into quite a volume, well, many volumes I should say. And back in the day, before photocopiers, we used to trace variable star charts, and so it was a very special time for me. Astronomy was very simple, but very much, a lot of fun for a young teenager. Now, around the time I got into astronomy, the Gisborne Astronomical Society opened up the Cook Observatory on Kitey Hill. How many have been to Gisborne? Okay, who knows Kitey Hill? Yeah, okay. So this used to be on Kitey Hill, and it was opened in 1971. And Peter Reid, who was a very populariser of astronomy back in the day, in the late 60s and early 70s, he had a TV program called The Sky at Night, I think it was. The Night Sky, that's it. And it was on every second Monday at 7 p.m. And I'd always be right in front of the TV watching Peter Reid. Anyhow, when I first got into astronomy, the observatory opened. Sadly, I didn't know it was actually being opened, and I missed the whole opening. But that sort of puts it in context when I got into astronomy. And the Society bought this telescope here, which is a 5-inch Watson telescope, and it used to belong to Peter Reid. And so he used to do a lot of his sketches and so on through this telescope. So we've still got this telescope, and it was just neat to actually have Peter Reid's telescope. So at that time, I got into photography and then married the two together, where I'd married photography and astronomy together to start taking photos of the sky through a box brownie. Did anyone ever used to use a box brownie back in the day? You're probably showing your age a little bit. Yeah. So very, very simple little camera to use. You look through there, the light comes in here, up here. You look through the viewfinder, there's your button there. And if you pushed it down, slid this across, you would actually keep the shutter down for a long exposure. So here's some of my first exposures. This one here. Anyone guess what this might be? Stars. Yeah, well done. Oh, well done. Yeah, so there's the Southern Cross there. Dink, 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 dink. So Southern Cross and the pointers there. So for me at 12-ish, 11, it was really quite exciting to actually record the stars and be able to see them. I didn't know anything about guiding at that stage. It was just sit it on the ground on a brick so it was angled, start it off, and then get the star trails and so on. And I think that was the chimney smoke, possibly.
Not nebula.
Sorry, what's that?
Not nebula.
Oh, no, yeah. Yeah. Okay, now at that stage, the Society was given an 8-inch reflecting telescope, and these young people here used to turn up to for the viewings. Terry Thompson, Colin Mazengarb, who's now a professor of geology, Richard Lee. these young guys here formed the Gisborne Astronomical Society. And so it was at that stage there that I got involved with the Gisborne Astronomical Society. And so I think the next photo shows me at one of the Gisborne Astronomical Society meetings, junior meetings. Yeah, so us juniors used to get up to a hang of a lot of dodgy stuff back then. So that is me drinking beer at about 12 years of age or 13 years of age. So yeah, we used to have some interesting meetings back then, but we did do a lot of stargazing, I must admit. So we spent a lot of time at the observatory on Kaiti Hill, and just here was a parapet. So this wall was about this tall here, and we would lie there on our stretchers with sleeping bags and look at meteor showers. So it was a really great place for meteor observing, and we would have people down here sitting on the couches there, and there would be a phone line connecting the two, and when we saw a meteor, we would phone them up. It was just a little light and a bell, you know, and they would hear it, and they would have the sheet and they'd be recording what we said, how bright it was, how long the magnitude was, the meteor was, and so on. So why we were doing this meteor observing was we were trying to confirm or other the Southern Radiant Index that Ronald McIntosh produced back in the 1920s, was it, Grant-ish? Yeah, 20 to 30s. So in Auckland here. So we would go up there regularly and observe these radiants just to try and, you know, see if they're accurate. True, if they were actual meteor showers, and we'd observe the known meteor showers too and send the observations overseas. Now each morning after an all-nighter that we spent at the observatory, this is the view that we had over Gisborne. It's just such a nice place to look out over, and very nice surf along these beaches. In fact, my favourite surf beach is just here, a place called the Pipe. Now, in 1973, in December of 1973, Comet Kohoutek came, in 1973 E1, I think it was, and we looked, the gas juniors, after an all-nighter, it was dawn, Corvus was starting to rise, Spiker and so on, and we saw the comet through a pair of 10x50 binoculars, and it looked really beautiful, I must admit. And something, when I saw that, it just opened my eyes up to comets, and I've always been interested in comets ever since. So as far as Possum Observatory is concerned, which we'll be talking about in a minute, why I call it Possum is I used to be married to this beautiful lady, Elizabeth, and I used to call her Possum. And there we are there. That's up at Waitangi, just after we got married. And she was a beautiful lady on the inside and out. It's not our baby, by the way. We were just babysitting that night. But I quite like the photo of Elizabeth there. So that was Elizabeth, and sadly Elizabeth. Oh no, one thing is that Elizabeth's godmother was Ernest Rutherford's granddaughter. So Ernest Rutherford had a daughter whose name was Elizabeth, and that Elizabeth was my Elizabeth's godmother. So there is a connection to Ernest Rutherford there. Okay, and sadly Elizabeth passed away in 1993 from cancer, and yeah, so that's why I call it Possum Observatory, just in memory of her. So for those who don't know, Gisborne is just there, and what happened is, well, there's a photo of Gisborne. Like I was saying before, it's a beautiful spot. And initially I had the observatory in Gisborne just down this area, but now it's out towards near the hills out here. Now, Possum Observatory was first built by Bill McLaughlin, and he had a C8 celestron, 8-inch celestron in there. Bill was a genius, and he actually designed the observatory so that the whole building rotated on a steel ring, the ring of a pea combine harvester with 8 rollers on it. So you would actually, it's quite neat, skateboarding when I was young came in handy, because what you do is you put your foot on the solid part of the floor and put the other foot on the outer part of the floor, and then you skateboard around and the whole observatory spins around to look at the new target. So Bill was the genius, but he was short, and when Bill passed away and he left me the observatory, and I kept on bumping my head into all the framework and all that. So what I did is I enlarged the observatory and made it have a larger floor plan to put a larger telescope in, a 16-inch telescope. So that was it when it was being built, and there it was when it was completed in about 2000. And you can see the roof used to roll back. Now it actually rolls to the side either way to reveal the sky. And it's quite neat because it rotates. What I used to do is friends would come in and I'd close the door and I'd rotate the observatory and rotate it into a tree, and they'd go, okay, let's go, and then they'd walk into a tree as a, so yeah. Very good. So that's the telescope that I had in it, a 16-inch f4.5 reflector, Newtonian, made by Meade on an equatorial mount, which tracked so that I could take photos in the time. And back then we used to use film, so that was measure 42 taken with film. Then in the early 2000s, the Canon DSLR came out, a camera that didn't use film but had a CMOS chip in it. So that really revolutionised astronomy, and astrophotography around the world basically just took off, exploded with these new cameras. This is one of the first photos that I took with that telescope. This is the pot, surprisingly enough. And there's measure 42, the Horsehead Nebula there, Flame Nebula, measure 78 down there, and so on. But immediately we saw that with these DSLR cameras, means digital single lens reflex cameras, they didn't suffer from what film suffered from, which was reciprocity failure. So with film, you would start the exposure and the sensitivity of the film would quickly disappear, would quickly fade away. And so you could take an exposure and it'll be really sensitive for the first few seconds, and then the sensitivity would die very fast. But with these cameras here, they keep the shutter open and it's still recording light, taking in photons and building up pictures. So yeah, so these cameras here proved very popular, and at that stage, I just spent as much time as I could photographing the sky with the DSLR camera. There's Omega Centauri with that set up there. In the 2005, we had an astrophotography camp in Taupo, and it was the first one in New Zealand, I believe, where the whole camp was just dedicated to astrophotography. Why? Because a lot of people were getting into the DSLR cameras. So we really had a great time there. It was absolutely freezing in Taupo, but it was a good time. And around that time, after that camp, well, actually during the camp, they suggested that I become the director of the Royal Astronomical Society of New Zealand Astrophotography section. So that's the position I held for 13 years until Jonathan Green. I asked Jonathan Green when I'd done my dash to take it over. Is Jonathan here tonight? Oh, hi, Jonathan. Yeah. So thanks very much, Jonathan. Okay, now, so at that time, I started getting a bit of a name with my astrophotography, and so I was asked to put some photos on some stamps. So that's my photo there, and that's photo there. I think that was Mark Cannell's photo there, Rob Beck, and John Burt was there. So in 2005, basically, I'd been looking for a place to live, and so I found a piece of land way out here at a place called Patutahi, which means a small isolated village. And you can see my house, that's that little speck just there. So it's about 10 kilometres from Gisborne city there. So, there's the house there. It's not the flashiest house, but Grant, you've been there. Jenny, you've been there, and yeah. but I have repainted it and recarpeted it, and it's really nice. The front half is beautiful. The back half is, yeah. Sorry?
You taught it?
No. Okay. So, that was the house. It had the shed here, which is very handy because now I'm using it for astrotourism. And there's a wide-angle lens view of the corner fence, and it's 2 acres of land there. Yeah, and the walnut tree, Jenny. So got a crane in, and we lifted Possum Observatory over my mother's house, and she would have killed me if it came down on the house, but nevertheless, it didn't. And you can actually see, you might be able to see the rollers around here that sit on the ring to make the observatory rotate. We put it on a truck, took it out to the observatory, and there's the ring, the steel ring that the rollers sit on. And there's my good mate John Burt, who no longer lives in Gisborne, and doing a lot of telescope maintenance and all that to finally get it up and running in Possum Observatory. So at that stage, we got the observatory going, and then we used to have things called Gizzy gatherings, where astronomers from around New Zealand, mostly around the North Island, would come and spend the weekend. You can see somebody's tent there, and we would use these telescopes and the telescopes they bought. So they were great fun. Some might recognise Frank Andrews there, John Burt, George Ionis there, myself, Dudley Meadow, and so on. And as time went on, the observatory started springing up like mushrooms. So this building here, you can actually just lean against here, and like I was saying, the whole building rotates. Whereas these ones here, the roof rolls off on these rollers here, revealing the sky. So, so I've kept building observatories, and I think the neighbours began wondering what they were. And the rumour around Patatahi was that they were chicken coops, that it was an egg-laying place. So I've had a number of star parties out there. This was a special night. This man here is called Jack Newton. Anyone heard of Jack Newton? Yeah, so Jack...
He had a Coleman sky and telescope.
He did, yeah. He was a very famous astrophotographer back in the 1970s, 80s, into the 90s and so on. So he and his wife came and stayed at my place for about a week, and it was really neat. So we had this great time. In fact, this photo here sort of reminds me of this photo here, which is in an astronomy book. When I was a kid, I looked at this photo and I just loved the fact that there's a bunch of people under the stars enjoying a telescope and enjoying the stars above them. To me, it was just very special. And so that night there was kind of like a fulfillment of that childhood desire just there. So astrophotography, yes, I got into it a lot. And for those who don't know what astrophotography is, basically it comes from the Greek words astra, meaning star, photos meaning light, graphe, to record, so to record the light of stars. And there's different types of astrophotography. You people probably know all this, but you can put a camera on a tripod like this, and without tracking on the stars, you can get reasonable images, but you can see that the stars are moving while the shutter is open. This was taken at Taupo, and you can see during the time the stars moved, people were moving around the telescopes, that strap there was blowing in the wind and so on. But it's quite effective, just a camera on a tripod. Then you can do photos like this, where you take an exposure of like a 10-minute exposure of Orion, and there's the pot again, funnily enough. And every minute, on the minute, I'd slightly defocus the lens so that as it became more and more unfocused, the star became more and more unfocused. You could actually see the colour of the stars easier. Instead of the point there or there, you could actually see the colour there. That was a technique introduced by David Malin, I believe. But still, that's just a tripod on a camera. Then, of course, you can take photographs of comets during the daytime. This is Comet 2006 P1, Comet McNaught. And at this stage, when this was photographed, it was 3 fingers from the sun. So you actually could lie under the eave of the house in the shade, hold your fingers up, block the sun out, and then go 3 fingers, and there was a comet sitting right there. So it was incredibly bright. How many of you saw that comet during the daytime? Okay, good, yeah. So it's one of those once-in-a-lifetime things, but you never know. Could be one in a year or so. perhaps. Then what you can do is take the camera off the tripod, put it on the back of the camera, and as the telescope is tracking, you're actually tracking on the targets. So the stars don't become trailed, they become basically pinpointy, and you can have a lot more range of targets you can photograph. Anyone recognise what this constellation here might be? Crux, yeah, that's right. There it is there. And the coal sack there, of course. So by piggybacking, you can start getting a lot more images, and the stars certainly are more pinpointy. This is quite an old photo, I must admit. I must update this photo here of the Magellan Clouds. Then you can take the camera off the back of the camera and take the lens out, put an adapter in, and then take the eyepiece of the telescope out and put the camera in and be taking photos through the telescope, so the telescope is acting like a big giant telephoto lens. And that's when you really start getting being able to photograph small targets, you know, things that aren't large in the sky. Like that one there was Jupiter and the Moon. Yep. Just about to be occulted. A few seconds later, about a minute later, the Moon covered Jupiter. Globular clusters, of course. Eta Carina. Just a massive star-forming place where this nebulosity, hydrogen and helium gas, over time will basically condense and form many, many stars and clusters and so on in this massive nebulosity. You can photograph in hydrogen alpha filter. With the special hydrogen alpha filter, you can basically bring out the emission part in the spectrum of what is called emission nebulae. So that's quite an exciting area to photograph. And the good thing about this sort of photography with hydrogen alpha is that you can actually photograph during the full moon, or even with light pollution, you can get through. But of course, the best thing, of course, is to get rid of the lights if you can. Measure 65 and 66 in Leo, a beautiful pair to look at and photograph. So those are examples. Oh, and this one here, the topsy-turvy galaxy. And I'll talk about this soon, but what I quite like doing is photographing galaxies for many, many hours and then really stretching them to try and bring out past events of cannibalism or tidal interaction and so on in the galaxies. There's my mate John Burt looking at the lunar eclipse. You saw the lunar eclipse here, didn't you? Did anyone do this trick here? What you do is you get out a coin or a washer or something round, and you actually bring the washer back and forth, closer or further away from your eye until the edge of the coin, the curve of the coin matches the curve of the shadow on the moon, and then once you get them matched, the coin in your hand will take up the size of how big the Earth is compared to the moon. It's quite a neat little physics trick. Actually, and another thing I did was not the last eclipse, but the one before, was photograph the shadow of the moon as it went across, hit one edge of a crater, timed how long it was until it hit the other edge of the crater, knew the distance between the two, and then you can work out how fast the Earth shadow is actually whizzing across the moon. So it's quite neat. You can do physics just with basic astrophotography. So my nightly procedure, basically there's a program called CCD Commander, and what you can do is you can put in a target, tell the telescope to move to that, for example, do a plate solve, then take a number of exposures, and then later on move to the next target, take those, and so on. So the good thing is, with the number of telescopes that I have at Possum Observatory, the complex I should say, 3 of the telescopes I can write scripts for, and then I just get out of the observatory, especially if I'm not in there, and the telescope, the computer will be telling the mount where to go, the camera what exposures to take, and so on. And then I just go and do visual observing. Or if I'm lazy, fall asleep on the couch, watching a movie or something like that. Then after writing a script for the night, basically I just let the telescope cool down. Not that it's cooling down in this photo here with the sun blazing on it, but it gives you the idea. It's good to actually just let the telescope cool down for a while so that the tube cools down and the distance between the primary and secondary doesn't change, and then you won't have to be adjusting focus as much. Collimate if you need to. Focus your telescope, choose your target, and then with CCD Commander it does all this stuff here, but this is an old photo of a program that was called K3CCD, but it basically just shows a guide star here, and what happens is the camera, the computer is telling the mount to move up, down, left, right, to keep that star under those pixels, on those pixels there, so auto-guiding. So you can then take long exposures, because the thing about photographing the night is it's not like photographing your cat during the daytime where it's 1/500th of a second exposure. For some of the things that we photograph at night, it can be, you'd want many hours of exposure time. So you do a multiple exposures and then you stack them all together to make one master image, and then you process that. So guiding is very handy, auto-guiding is very handy. Back in the day, up at Cottee Hill and in Possum Observatory, I used to manually guide where you had an illuminated reticle, a red cross, and you'd put a star behind the red cross, and then you'd have to sit there physically turning your, it was right, RA, 2 buttons, and declination was a knob to keep that star behind the crosshair while the exposure was being taken. It was very, very patience-building work. I mean, sometimes, the number of times I was upside down because the telescope was in a strange place, upside down like that for a whole hour at 3 o'clock in the morning, manually guiding on a guide star was, quite demanding. So yeah, thank goodness for auto-guiders. How many of you remember the old manual guiding days? Grant, yeah? Yeah, okay. So it was quite demanding. Then if you're using a DSLR, you can use the remote controllers, or there's programs like Backyard EOS where you can actually set the number of exposures and take it. Or if you have a CCD, a program like Maxim DL will be taking the exposures for you and so on. I also like just recording some of the details about that night and the exposure and so on. I've often said that probably the best astrophotography book is your notebook. You record all the information about your exposures. The good ones that work, you go back and look at what happened, what you got right and so on. The ones that don't work, you look at it and say, I'm not going to repeat that. So you get your exposures. That's just an example of one exposure. Then you process it. You might stack all your images together, put them in your computer, and you go, oh my gosh, there's nothing there. And then you process it, and then it looks a lot better. So here's some software for astrophotography. Maxim, Photoshop, PixInsight is a very, very powerful one, and so on. Now, regarding PixInsight, it's a software program written specifically for astrophotographers by astrophotographers. It's very powerful. It's about $360. It's got a steep learning curve, and here's some of the tools that are actually in PixInsight. And here's just an example of I was photographing Barnard's 30, I think that says up there, just with a lens, and that's it before you start processing, and then you start processing and start bringing out the detail until you get your sort of final image. So I've got a lot to learn in PixInsight. Jonathan, do you use PixInsight yourself?
A little bit.
Yeah. I mean, it is a big learning curve. So what do I do with my telescopes now? Well, still astrophotography, but I've probably evolved more into science. So it has been an evolution over time. Any Star Trekkies here? Yeah. So Grant, probably about 10 or 15 years ago, impressed on me the importance of using my astrophotography equipment and skills to contribute to science. And the interesting thing is that there's not a lot of people in the southern hemisphere. 80%, what is it? 88. It's about 80% of the world's population is in the northern hemisphere, 20 in the south roughly. So most telescopes are in the northern hemisphere. We can see things that people in the northern hemisphere can't. So it's really good to actually try and do some science that people up there can't see. Of course, nowadays with remote observatory, that is changing a bit. So since probably for the last 15 years or so, I've been doing quite a lot of science with my setup. Yeah, 88% of the world's population lives in the northern hemisphere. So there's times when these people can't see comets that we can down here, and so it's really quite important to actually try and monitor these comets and keep an eye on them, just to keep sending your results in so that people around the world can see what's happening to them. Now, for those who don't know, in the sky there's a thing called right ascension and declination. It's kind of like latitude and longitude on Earth. Sorry about this, having it for New Plymouth. This is from a slide a couple of months ago when I was there. But using latitude and longitude, you can get down to pretty much, the armchair in a house with your latitude and longitude. It's that precise. And it's like that with the sky. You have your declination going here from the south celestial pole, and the right ascension going around here, these lines here. And so by knowing the right ascension and declination, you can then pinpoint a star. And if you photograph a comet, and put it in a program, it'll tell you the exact right ascension and declination and the magnitude of the comet, and you can send it overseas so that other people can use it. So when I'm doing astrometry, basically I take quite a few photos. Here's a typical example of a photo of a very faint object that night, and calibrate the images, and basically run a pinpoint program of them so that it determines anywhere on the frame what the RA and declination of the spot will be. And then I use a program called Astrometrica, written by Herbert Rabe, to stack probably about, it can be 10 exposures, 20 exposures, depending on how fast the object's moving, and get about 3 or 4 master exposures. And for example, I might take those 5, those 5, those 5, and so on, put them into Astrometrica, stack them all together, and this is basically a screenshot of it aligning the images. And then when it's aligned the images, it knows where the stars are and where any spot that you click on will be, because it knows the position of those stars very accurately. And then you can start blinking your images to see the target moving, and you click on them to see the object. Now, this is a test for your eyesight. This is a very faint comet. It was just newly discovered, but it's really faint. We'll just see if anyone can actually see the moving target. And I'll give you a clue. It's pretty much in the centre of the frame. Can anyone see it? Yes. Okay, we're looking just there. That's a bit of a streak, but anyhow. But yeah, you can just see it. So what you do is you find the target, the moving object, and click on it, and then Astrometrica will give you the right ascension and declination and the magnitude, like that one was 18.85. And so you click on the 3 images, and Astrometrica then produces a report, and you send it off to the Minor Planet Centre. And I also send it to other astrometrists around New Zealand, just to show them what I've been up to. And so this data here, this comet here, well, the newly discovered comet at this stage was called A10WOTD. Date, 2021, month, day to the decimal point, RA, declination, and then your magnitude just here. So these observations are sent overseas and meshed with other people's observations. So I'm E94, so there's my observations, and there's Mount John Observatory there, and a few other observatories. And then if you get in quick enough, you can actually get the observations in fast enough, you can be one of the first people in the world to image the comet, and then a confirmation email is sent out from the Minor Planet Centre, and that's sent to astronomers around the world. So you can see here, there's Mount John 474, and so what you do is look down here for 474. There it is there. There's Mount John's observations there. I'm E94, so there's E94 there. And F51 was Pan-STARRS, the Pan-STARRS Synoptic Survey Telescope. And you can see that they got a lot of observations with the initial discovery images and so on. So it was quite neat. I was the second person in the world to photograph that comet. So it's quite, and here's some photos of another comet, just to show you that they're not always faint. There it is there. You can just see it moving through the sky, and you can see a little tail coming away from it too. So astrometry is something that I find really interesting, and it's good to contribute your findings to overseas. Another thing that Grant and Jenny got me into was using my telescopes to search for exoplanets. So it's quite neat that in the universe there's just so many planets that we know of now, probably getting up to, 4,000 or 5,000 exoplanets. Exoplanets being planets that go around other stars. And so now with today's technology, we're discovering these planets going around other stars. And the first exoplanet that orbited a normal star was in 1995. It was going around the star 51 Pegasi, which, for those who know the Great Square of Pegasus, here's the two western stars, and it's sort of sitting just off to the side. So that there was the first planet to be discovered. That was an artist's impression of that. So there's different ways to discover them, and those are some of the ways that you can use. Now, microlensing is the way that Grant and Jenny have discovered a lot of their exoplanets, and Tim Natush. And you can see that we don't discover a lot of planets, primarily because the transit method of discovering planets has been done by the Kepler space mission. So they've discovered a lot of them, out in space. But you can see, nevertheless, that microlensing has discovered a number of planets. And Ohio State University, under the leadership of Professor Andy Gould, encouraged astronomers with small telescopes to try and take photos of stars that they would recommend you photograph. There's Ohio State University there. And they basically tried to get people in the southern hemisphere who had the heart of the galaxy that slides over our head in winter, and there's other times, of course, when you could image it, to be imaging these stars that they tell us. Because what happens basically is when a star comes in front of a background star, the foreground star has mass, and because it's got mass, the starlight that would have gone there, gets bent around the mass at the front and gets bent like that and basically focused down here. So this background star basically appears to get brighter by the foreground star's lensing, microlensing. And sometimes what can happen is you have the main star going in front of the background star, and with the mass, the Einstein ring, it'll actually appear to get brighter over time. The star perfectly in line, so to speak. You reach a peak, and then the foreground star, the stars start drifting away from each other very slowly. Not that you can see stars naked eye moving across the sky, but these are just happening at vast distances under a lot of magnification. You can pick it up. But now and again, instead of two stars being lined up, a planet can actually come in between you and the background star, and the planet has its own mass and little gravitational field, and that will also magnify the background star and give you a little blip. And so what Grant, Jenny, Tim and I would do is we'd send the observations off to Ohio State University. And Mount John Observatory is very instrumental in telling us, they'd be photographing the bulge of the Milky Way and basically looking for stars that would start brightening up and then possibly being a microlensing event. These people and Ogle in Chile and basically Ohio State University would send out an alert and tell us to photograph these stars. Here's an example of a microlens. So you can see the star, this one here, is getting brighter, brighter, brighter as the two are starting to align. And then a couple of days later, that's August the 12th, 16th, the alignment's gone and the star basically disappears, so to speak. So it's a very effective way of discovering planets. And it was really nice. A few years ago, Grant, Jenny, myself, Tim, and a few other New Zealanders and other people, you can see on the list of authors there, discovered a terrestrial planet in a 1 astronomical unit orbit around one member of a binary star system. So that was quite an important discovery because, it ended up in Science, in the journal Science. So there's Grant there, myself, Jenny, Tim, and so on. So thanks to Grant and Jenny for getting me into exoplanet discovery. It's quite neat that we've helped discover, about 20 or more planets going around other stars. Now, besides that, at Possum Observatory, I periodically look at minor planets going across stars. Now, in this age of basically huge telescopes, space telescopes and everything, seeming to overtake amateur astronomers, this is an area that will probably still be very effective for many years to come, where you have an asteroid going in front of a star, and the asteroid will actually cast a shadow on Earth. And if you get enough people looking at that star and then timing when the star disappears and then when the star comes back on again, then you can actually work out the size and the shape of the asteroid. It's a very effective method. It's a really cool way of contributing to science. So this is for those who don't quite get it, this is an observer here, this is an observer here, this is an observer here, and so on. So if you get enough people along the chord, then you can get when you're looking through the telescope, you'd see the telescope, see the star, and how I do it was with a microscope, not a microscope, a tape recorder and a clock with chirps, timing signals, and I'll be recording the radio, and I'll say star on, because you're looking at the star right in the centre of your field, star on, off, on, because you'd see the star disappear as the asteroid went across the star. Then it came back. And then, but because of that, they would put your cord there. They knew when it went off, when it came back on, and then they'd measure it with other observers, and there's your shape of the asteroid there. So it's a very effective method. In fact, Graham Blow here was very instrumental. He's like the father of occultation work in New Zealand for many years. Sadly, Graham passed away a few years ago, but he certainly left an occultation legacy that's known around the world. So thank you, Graham. So there's a program you can get called Occult Watcher, and basically you put in where your observatory is, and it updates, goes on the internet, updates these are all the events that might happen, and it highlights the ones that will be good for you. And then it will tell you how long the occultation will be, how much the magnitude will drop, and so on. And then you can start observing. So you don't need a big telescope. You can do it with a tape recorder and a beeper that's accurately timed, because timing is essential, that you get the time right, and away you can go. Now, another thing I'll be doing at Possum is a little bit of spectroscopy. And basically, spectroscopy is when you get a starlight and you split that starlight, the white light, into the spectrum. It's kind of like the rainbow. You've got the sun over there, the rain droplets, and the rain droplets are actually breaking white light into the colours, and you can see the rainbow, the colour of the rainbow. And that's what spectroscopy does. It basically has the white light being split into the colours. But not only the colours, but it actually also can show you what's called emission lines and absorption lines. And these are very important because every gas has a fingerprint, as it were. Humans have fingerprints, different fingerprint for each person. Gases have fingerprints, different fingerprints for each gas. And so if you have these lines here, you know that that, for example, might be hydrogen, for example, or it might be oxygen or whatever. If it's, you know, those three would be just that one particular gas, or the absorption lines there. So here's some spectra of different types of stars here. And you can see that some have strong absorption lines here, and so on. So yeah, it's kind of like a fingerprint of the gases that are in the star's atmosphere. There's some great books. This is part of Patrick Moore's Practical Astronomy series, Spectroscopy, The Key to the Stars. Now, one thing that astronomers do is, with spectroscopy, we can look at stars or galaxies, I should say, and we can actually tell if they're moving towards you or moving away from you based on the spectra. So you can actually see here, let's see, so this one here is spectra at rest. You might have a galaxy and it's giving off this light here, and these are emission lines probably in hydrogen alpha, just sitting here, if it's at rest. But if the galaxy is moving towards you, see these two lines here that should continue up there, they've gone to the blue end of the spectrum. And if they're moving towards the blue end of the spectrum, it shows you that that spectra is moving towards you, that object is moving towards you. If the lines carry these two down here, they've actually moved towards the red part, it shows you that that object is moving away from us, redshifted. So one thing I did is got a star analyzer. This has 100 gratings per millimetre, hence the name, Star Analyzer 100. And here's some spectra of the jewel box. And so that star there, there's the spectra going along there. That star there, there's the spectra. Now, it's a little bit fuzzy in this picture, but there are emission lines and absorption lines and so on. So what I did is took a galaxy, a quasar, 3C273, and there's the spectra there. Now, I know those spectroscopists out there do know the source should be on the left-hand side, but I was that new, I didn't quite know that at that stage. But got the spectra of the quasar, and here's a spectra of the galaxy, and this is where hydrogen alpha should normally be, just sitting here. But you can see that the spectra is actually has moved down to this end, to the red end of the spectra. That spectra there would have been there at rest, but it's actually moved. And based on this movement, the red shift, just did a little bit of maths, and based on that, I was able to work out that the distance to that quasar was 2.144 billion light years away. And it's really neat that you can actually do this with a $100 piece of glass, a bit of software, and determine the distance to galaxies and quasars a long way away. So it's really, really good fun. Here's another one with spectroscopy where I photographed Uranus and Neptune, and then you put it in R-spec, and then click on methane, and there's the absorption lines in methane just there. Methane, 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 methane. So based on that, you can then know that methane is in the upper atmosphere of Uranus and Neptune. You don't have to visit the planet, all because of spectroscopy. So spectroscopy is a very interesting thing. I've just dabbled a little bit in it, but I know some people are really into it, like this man here, Tom Field. And if you do get into it, he will just bend over backwards to help you. In fact, he's often encouraging people to get into spectroscopy with their kids in science to try and find the fingerprints of gases by having a light and then shining the light through a gas and seeing the spectra. Some people even take spectra of meteors, and based on that can work out the elements in the meteors. So talking about meteors, I think this is nearly finished. I'm nearly done. Meteor observing is a very fun thing to do for observing. All you do is look at the meteors like we used to do when we were trying to confirm or otherwise of Ronald McIntyre's list, and you just need your eyeballs. Get comfortable, lie on a couch, look at the stars, and maybe write down, record on a dictaphone the magnitude, how long they went, shower or sporadic, and so on. Not that you'll see meteor showers like that all the time. That was, you might see one every 3 minutes or so. But it's great that you can actually send your observations overseas to the International Meteor Organisation. And for this shower here, for example, the Edda-acquired meteor shower, they then put you on a map to say that you've observed that meteor shower. So it's something I love doing. I don't do it nearly as often as I should, but it's great to be contributing science to the world, national, international science community. And here's a couple of photos I've got of meteors during the Edda-acquired meteor shower. So, and there's a photo of Comet Schwarzmann-Whacken 1, and a meteor went through the field, and you can see it sort of getting torn up in the atmosphere. Oh my gosh. Yeah, and one other thing I've been doing is deeply imaging galaxies. We'll just quickly go into this. So basically here's a typical image of a galaxy, and then I try and take as many exposures and really stretch it out and start seeing the tidal interactions and so on. So here's just, let's see, here's another galaxy, the Topsy-Turvy galaxy, and you can, that's normal light, and then that's with hydrogen alpha filter just to see if the gases were getting excited in the galaxy. And then you really stretch it, and you can see some weird things that are happening as the galaxies are interacting and ripping each other apart and so on. And then using the small angle formula, you can work out the sizes of the galaxy and some of the arcs and so on. Here's another galaxy. Not my photo. This is a radio telescope, and you can actually start seeing some of the things that are actually happening in that galaxy as these interactions are happening. And then photographing into the core of the galaxy. There it is there, that's my photo there, and there's the Hubble Space Telescope photo there. So it's quite neat to actually try and replicate some of the stuff that Hubble is doing in the core of galaxies. So recently I got my Masters of Science from Swinburne University, was made a Fellow of the Royal Astronomical Society, thanks to Nalini Davies for nominating me, and John Hernshaw, Professor John Hernshaw, and recently started up at my astrotourism business, and that was a shed before we started, and that was a shed after, Gisborne Astro Tours, and I give the people a talk about astronomy for about 30 minutes, and then we go outside to the roll-off roof observatory, and it's got this nice decking around, seating where people can sit under the stars too. We look at through a 20-inch f3 telescope, 50 centimetre. These are some members of the Gisborne Astronomical Society. There's one of the city councillors there, and that's the telescope there. So it's been, the tours are going well, keeping me busy. And when I'm not doing that, I'm basically using these telescopes here for comet observing, galaxy interactions, exoplanets, and so on. So that's what's been happening with Possum. And just recently, I've just started a PhD with Wayne Orchiston, Professor Wayne Orchiston. He asked me if I'd like to do a PhD on the history, New Zealand's historical involvement in the study of comets. So I've just started that with the University of Southern Queensland. And so Wayne and I and Gary Cronk in this paper here have been writing papers about old comets and New Zealand's involvement in those comets. And that's my other supervisor there, Caroline Brown. So between the PhD, school teaching, the astronomy, astrotourism business, regular observing, surfing, school teaching and everything, I'm just sort of kind of busy. So, and then of course, Gareth and Nalini encouraged me to come along with them on their tours as we go around New Zealand, telling people about astrotourism, teaching them about astronomy and so on. That was actually going across, flying over to the Stewart Island, so good old Gareth doesn't look that healthy at that stage. But yeah, so it's really neat to actually get out there and tell people about astronomy, and with Nalini and Gareth, just show them how to use the telescope, show the people how to use telescopes and so on. This is Tiano just a few months ago, and so on. So John Hernshaw has just recently started this, the Aotearoa Astrotourism Tourism Academy, where people can then go and be taught about astronomy and starting up businesses. So John and Liney and Gareth and a few others and myself are basically part of that team. So it's a busy life. So thank you very much.
So those photographs you had the stars in black, was there a reason you didn't do spectroscopy or?
So the stars are black and Yeah, so for the galaxy interactions, basically I found that if you do invert the images, so the stars are black and basically you can just see it sort of better, see it nicer. It's kind of like the number plate in New Zealand. We used to have the white letters on the black number plate. Now it's the black on the white and it stands out better. Oh, okay. Yeah.
Are you finding with more and more
man-made satellites in the sky, they're sort of affecting your results or output in a way and being able to mitigate?
Yes, there are times when with a wider field exposure, then you do see more meteors coming through, but with a narrower field for longer focal length telescope, not so much, but there are times you do. And with the astro tours, it's a pain sometimes. Actually, I must admit, people go wow when they see a continual stream of satellites going across the sky, but I'm thinking my camera's taking photos over there and it's probably picking them all up, but it's, yeah.
Is the surf still good at Gisborne?
Definitely. Do you surf? Yeah. No, I'm still getting out probably about twice a week, sort of thing. Doesn't show sometimes, but yeah.
Robert, you had a question, I think?
Where could you find more information on how to get into the science side of?
I'd go to Grant and Jenny. They've got a wealth of knowledge here and other people in the audience. But there are, of course, books. Patrick Moore put out a whole series on different fields of science that you can get into, internet. And if there's an area that does interest you, you'll soon start to hear some common names, people that you should get in touch with, and then they can possibly put you onto doing more science for them or whatever. Yeah.
I should mention, John, some of the newer members may not be aware the Society own a telescope out at Possum Observatory, and there's a group out there led by Jonathan Green who are doing similar things to Grant and Tim and Jenny. So there's opportunities to learn how to use that equipment. If you are interested, talk to Jonathan. I believe you're training a few people at the moment.
Yeah, that's right.
Yeah, we've got a team of 4 of us at the minute, and if there's anybody else interested in getting involved with some of the science stuff that John's doing, particularly sort of microlensing or just astrophotography, come see Jonathan or Orion, and you've got some time, and Kumi's convenient for you.
Yeah, we've got a brand new, or virtually brand new, astrophotography purpose-built camera, but it's got a full-frame size sensor. If you're familiar with DSLRs, you have different size sensors. Full frame is sort of equivalent to 35mm film, so you get a really big field of view with a camera like that. And it's the latest type of sensor as well, so it's, if you're interested, you talk to these guys. Anything online there?
Must admit, I love joining in on Monday nights to your meetings. I've got my alarm set to go off at 10 to 8, so I can actually sit in the background and watch the speakers. So thank you very much for that. Sorry, what's that? Oh, yeah, I wouldn't have listened to it anyhow.
So I just got a text from Jarena who was bringing the supper, but unfortunately she was getting a lift with somebody and the person giving her a lift has got lost. So unfortunately we've only got tea and coffee out here at the moment. So unless Jarena turns up fairly soon.
That's like, see you arrive, stand out of the way.
But anyway, I'd like to again thank John very much for a really fascinating talk. I hope it was inspiring.
Thank you.